Hello, welcome back. In this lecture, you're going to learn how to measure the return on any financial asset. You will learn how to compute the holding period return over any given period. You will also learn how to compute and use the arithmetic and geometric means. Finally, you will learn about the expected return concept and how to compute the expected return on an asset. So the return you make on an asset for any given period is pretty straightforward to calculate. You just need to make sure you account for all the cash flows over the holding period. So let's suppose that you invest in a stock index fund today, and the fund currently sells for $100 per share. And let's suppose that your horizon is for 1 year. Now, the return you make, your realized return on your investment over that period, will depend on the price per share at year's end, plus any dividends or any other cash flows, basically, you will collect over the year. Let's suppose that the price per share at t equals 1 is $105. And let's say that over the you also collected cash dividends of $5, right? So your return over this period, or your holding period return, is given by, typically, I'm just in general, right? It's going to be the ending value plus any cash flows you receive, right, divided by the beginning value minus 1. All right, in this example, it's going to be the end of the year price plus the dividend that you received, right, divided by the initial price minus 1. Or we can say it's 105 plus the $5 cash dividends you received over 100 minus 1. So your one year return was 10%. Okay? All right, so now this time let's suppose that you have a short time series of annual holding period returns for the S&P 500 index for, let's say, for a 5-year period. In this table, you see in each row the annual realized return for that year. Okay? So we can ask a number of questions. So for example, what was your 5-year return? Right? So in other words, so suppose I have, right, 1, 2, 3, 4, 5, right? What was the 5-year return? What was the return you earned over that entire period? In other words, suppose you invested $1, right, at the beginning of the first year. How much would you have at the end of year 5, right? So you compute that by, let's say that these are the returns for each period. Right? Basically, I'm compounding these returns over the 5 years. Right? And based on the numbers we have in that table, that would equal to 1.0275. So $1 invested at t equals 0 will grow to $1 and 2.75 cents, right? So that means your 5-year return was 2.75%. Right? Now, let me ask a different question. What was your average annual return over this 5-year period? Right? So now I'm looking for that one constant return that's going to get me to the same point, right? Well, I'm looking for basically, all right, these are my annual returns compounded, all right? I'm looking for that constant return, average return, such that I get to the same end point, right? Well, if you plug in the numbers and solve for this RG, that is going to be 0.54%. All right, so this is the geometric mean. All right, so this is sort of your average annual compounded return. This is the constant annual return that you would have to earn to get to the same endpoint. Right? Now, the geometric mean is useful in measuring performance over a past sample period. So in general, right, suppose we have t periods, geometric mean return, let me call that RG, right? Suppose you have annual returns over t periods, right? What is the geometric average? Well, it's that return times RT, 1 over t gives me the 1 plus the RG return.